I'm Doug Loon, the semi-new president of the Minnesota Chamber. I joined the organization a little less than a year ago, and it's my distinct pleasure to lead an organization that I've greatly admired for a long time for the great work that they do on behalf of the Minnesota business community and promoting the state's economy. Today we're going to have a discussion, a bit of education, a little bit of discussion about how the Midwest can lead the way in a zero carbon dioxide emissions standard. And we have a fantastic panel of speakers with us today to help educate us about one new clean coal technology called the Allam Cycle. And we'll hear about how government, environment, and business can learn about that, potentially participate in it. As all of us know, the Clean Power Plan finalized in 2015 has a standard for Minnesota to reduce its carbon footprint by 40%. Now we know the Supreme Court has held that back with a stay for now, but we certainly recognize that we are facing a carbon-constrained world going forward, so it's in all of our interest to come up with technologies that work with that. And to move Minnesota forward to build a healthy economy for all Minnesotans, which is a key priority for the Minnesota Chamber, we want to look for how do we make sure we have reliable and affordable electrical rates to keep the state competitive. When you have a minute, go to the Minnesota Chamber's website and you'll find on there what we call our business benchmarks report. Earlier this year we produced this report looking at 6 fundamental areas of what we consider make up the business economy in Minnesota. And it is, in those 6 areas, basically setting a performance measurement for the state. And one of the areas that we looked at is the cost of energy, because we know businesses look at the cost of being in business, whether it be in the tax area or the regulatory area, healthcare costs, employment costs, and certainly energy costs factor into that. So it's in our interest to work with utilities here in Minnesota and with the business community to make sure we have a competitive structure going forward and a reliable structure as well. And certainly we need to have a competitively priced electricity, as I mentioned, through an all-of-the-above approach. And our utilities, I think, here in Minnesota reflect on that very well, that we have all of the above: coal, natural gas, nuclear, and certainly renewable energy to help make sure that we have a competitively priced structure. The Lignite Research Council that we partnered with for this event today has been working to develop electricity generation technology with a near zero emission goal. Mike Jones will be on the panel here in a minute talking about the new technology that they are talking about, which is the Allam Cycle, which uses pressurized carbon dioxide rather than steam to generate power more efficiently. But before we get to the speakers, let me thank our key sponsors. First of all, the Coalition for Secure Energy Future is our event sponsor. Associate sponsor is Minnesota Power, and certainly our venue sponsor, Bar Engineering, for opening their doors to us today with this fantastic. Without further ado, Joel Johnson, who is Director of the Coalition for Secure Energy Future, will moderate our panel. Thanks, Joel.
Thank you. And thanks again for showing up. It's funny hearing John say, you know, how excited he is just from an engineering perspective to learn about this stuff. And it really is kind of fun to be in a room of people that find this interesting and really, really cool. You know, I go home and I try to talk to my daughters about what I'm doing and what I'm working towards, and you know, soon you see their eyes glazing over and they're waiting for me to kind of finish and just kind of nodding like that. So thank you all for being here. I'm going to call up our panel right now. And I don't know, if we step away from the mic, is it loud enough in here for you guys?
Not better.
We do have handheld mics. What would you guys prefer?
My voice going to carry okay?
Yeah.
Okay. I just...
Okay. Yeah. First up is Mike Jones. Mike is a PhD, is the Vice President of Research and Development for the Lignite Energy Council. With over 25 years in the industry, he's been a senior research advisor at the Energy and Environmental Research Center and an adjunct professor of physics at the University of North Dakota. A graduate of Bemidji State University, he earned his master's degree and a doctorate in physics from the University of North Dakota. He has also authored or co-authored over 80 publications. So, Mike, we're going to hand it off to you first, and I think your slideshow should be up.
Okay. Thanks, Joe. I'm just gonna be up here, is that okay? Is that gonna work for everybody? Can you hear me okay? Well, first of all, I appreciate the invitation to be here. It is a pleasure to be back in Minnesota. I grew up in northern Minnesota, still have a home up just south of Bemidji on one of the lakes up in that part of the world. In fact, I drove up from there this morning. Kind of hard to leave and come down to the city, but I still had to do it. And look forward to just sharing with you a little bit about some of the exciting things that are going on. As Joel mentioned, I am the Vice President for Research and Development at the Lignite Energy Council. And if you're not familiar, let me just say a little bit about the Lignite Energy Council. It is a trade association. And we think of ourselves as a regional association, mainly because we're focused on a resource which is regionally distributed. And it's really centered around North Dakota, but extends out into Montana, up into Saskatchewan, and it is a very large. It's the largest lignite deposit in the world outside of Australia. Happens to be in the state of North Dakota. There also are a lot of lignite resources down in the Gulf Coast area, Texas, Mississippi. Probably heard a little bit about Mississippi and their lignite because they've got a project they've been working to put forward at Kemper County that uses that particular resource. Well, our organization is made up of about 250 different groups. That includes the groups that do make use of the lignite, and that's really power plants, basically. Although we do have the coal gasification facility at Beulah, North Dakota. And then, of course, the mining groups. There are 4 different groups that do mine the lignite in North Dakota, and they all play a key role in that. But what we've tried to do is to bring that together with the other groups that do really support that industry. Because just the power plants and the lignite mines won't make it happen. It's everything from engineering groups to groups that might work with scaffolding, that might do safety, any number of things that are all a critical part of that industry, and we've tried to work together. But what I'm here to talk about is what's a key part of that organization. I think uniquely, when I joined this organization about 7 years ago, it was because I felt it was unique in many ways when you talk about regional trade associations, because there's a very strong focus on R&D. There was a partnership that was established with the state of North Dakota in that industry many years ago. Basically, the understanding was that it is an industry which is based on technology, which means you better continue to work to develop and enhance that technology if you're going to have a viable future. And that's really been a key part of what's happened. About 2 years ago, the group sat down with me and said, listen, we need to have a roadmap. We need to talk about our future because we're never going to have enough resources. We're always got a number of questions. So let's try to prioritize where we are and where we're going. And this is something that isn't a document that we did 1 year and put on the shelf. It continues to evolve as times change, as the constraints on the industry change, as our opportunities change. And so we do that every year, take a good hard look at it. And really what they've told me right now is that we've got a few different priorities. Number one, the lignite industry in North Dakota probably has assets, and we would estimate probably a value of about $25 billion. And very much at risk right now. You may have heard there was a closure of one of the coal plants. It wasn't a lignite fired plant. One of the coal plants in North Dakota just closed. And a number of forces acting on that, but they said, what can we do as a developing group? That's where I came in on the R&D side, that really enhances that opportunity for the future. And so we talk about what can we do with the existing facilities to allow them to continue to be competitive and be a valuable asset in the community. A critical thing. But secondarily, they said, we know and understand that as we evolve, we're not going to just build a plant like we did back in the 90s or the 80s when we put these in. The next one will be different. So what is that transformational technology that you think has that opportunity to carry this industry into the 21st century with a viable opportunity for the long term? Interesting challenge, because I think, as you all know, there are a number of issues and constraints that we are facing as an industry. And really that came down to a focus on CCUS. Now, if you live in my world, I say CCUS, it's, yeah, I know what that is. Not everybody does. It's carbon capture, utilization, and sequestration? In other words, is there a value proposition with CO2 that we can talk about? Not just as something that we need to deal with, but what is the value proposition here? Can we make that into a positive? And then finally, knowing and understanding that what we're trying to do is not easy, it's not cheap, it's not going to happen quickly. Where are those relationships that we can build that will help us be successful with that? And that meant looking internationally. What can we do? And then how do we leverage that to try to make some of these breakthroughs a reality? This is just, I put this up because I think it's a unique partnership that has occurred in the state of North Dakota. This happened, it started back in the late 80s, early 90s. I don't remember the exact year when the program began. Basically, the legislature said we're going to set aside a portion of all of the funds that we collect on tax revenue from that industry and put it into a fund that will make investments for the future. And that continues to today. We probably, are getting something on the order of $4.5, $5 million a year that we've invested. To date, we probably have had projects that we've been a part of with a value of something over $700 million. In other words, it's been highly leveraged, trying to look at a number of these issues that we see going forward. One of those has been what we call in our transformational technologies. And what do I mean by transformational technology? Well, it's one thing if you go out here to Sherco Station, which I think many of you are at least familiar with. It's a series of coal-fired units firing subbituminous coal. And they are equipped with environmental control technologies which limit sulfur oxides, nitrogen oxides, particulates, working on mercury, all of those things. Probably have an efficiency something, I'm going to say low 30s. I don't know exactly what those units are, but that'd be a pretty good guesstimate on what you can do with that. And as I said early on, I don't believe that we're going to go out and build another Sherco station. I just don't think that's going to meet the needs for the future. So what is it we can do? And there's a few things we've been talking about. Allam Cycle, we already heard. And I'm going to talk more about that, so I'm not going to focus on that right now. But chemical looping. Basically what chemical looping is, when you try to use any of the fossil resources, basically what you're doing is liberating that chemical energy. In other words, you're oxidizing it. And you're using that energy you've liberated then, in most cases, to form steam, which you can use to drive a turbine, and you can transform that from that thermal energy into some mechanical energy now that can be used in many different ways. So with chemical looping, basically you're using a solid sorbing material that carries oxygen from the air to wherever you want to use it in that system. And so you essentially can have a pure oxygen-fired thing without having an oxygen separation device, which is a very large energy pig is what it is right now. So it's an issue for us. It offers some unique opportunities, but it's early on. We're talking about that. It's being done on a laboratory scale, I would call it right now, and I think it has some potential, but we've got many years to go. Pressurized oxy-combustion. In this case, what we're trying to do is to use a pressurized system, again, replacing air with oxygen, so that we have a pure stream coming out the back end. Well, one of the things you see right off the top then, if you're not burning it in air, that 80% nitrogen we talk about, which is can form what we call thermal NOx. In other words, if you heat up nitrogen high enough with oxygen around, it's going to oxidize. And so you're going to have an oxygen or a nitrogen oxide stream coming out the back end. That's gone. If you don't have any nitrogen there, you can't form nitrogen oxides. So a big plus there. And also your efficiency equations change when you go to those higher pressures. So there's some things we think that offer an opportunity there. To date, we haven't seen that as that earth-shattering one that we hope we found with the other one. But what we're talking about, what we see right now is our solution for where we are today is something like the Allam Cycle. Now, why do we get excited about that? Let me just say right up front, the big thing that we see here is, again, this is going to be an oxy-fired system. We're going to do this at very high pressures. And I'll talk just a little bit about that when I show you a schematic in just a minute. And we will produce electricity. In this case, the working fluid is going to be supercritical CO2. It's not going to be steam any longer. So you've got a whole thermodynamic set of equations you're dealing with here. And secondarily, because we're burning now a hydrocarbon in pure oxygen, the back end is going to have basically two things, water and CO2. We can knock out the water fairly easily, so now we've got a pure stream of CO2 coming out the back end. So we have that potential in a place where we can put that U back in the CCUS and find a use for CO2 to have a second revenue stream. And that's what really has got us excited right now. We have an opportunity which is going to allow us to deal with all of the CO2. We're not talking about a 50% reduction, we're not talking about a 90% reduction, we're talking about capturing all of the CO2 that comes out of the back end and being able to use it. And we may actually produce water too. We have another benefit there. So why are we excited about that as an opportunity in North Dakota? Well, in case you hadn't heard, there's been a little bit of an oil boom out in North Dakota going on. And even though prices are down, there still is a lot of activity. And one of the things that people keep talking about is, what are you doing with that shale? How much of that oil are you taking out of there? Well, we're talking about, the averages I see are probably around 5%, rough average. That means 95% is left in the ground. Now, is there an opportunity to take and use CO2 to force more of that out? We think there is. In some of the research we're doing, and again, we're part of that, looking at opportunities to make use of supercritical CO2 in those shales, may allow us to take a tremendous amount of that. All of a sudden now we have a value proposition which is significant for the CO2. It's no longer a problem, it's an opportunity. So we're excited about that, and we want to see what we can do to put all of these things together. This is a simplistic situation that shows you what I'm talking about with our Allam Cycle. Now let me just start. I don't know if this has got a laser on it. Maybe not. I can probably just point out some things here as we start down through the top. You start down from the, I'd call it lower left, where it says ASU. That's an air separation unit. I said before, we want to talk about doing oxy combustion in this case again. So we're going to have an air separation unit on the front end. What we're going to use, though, to form that fuel is a gasifier. So we're going to be burning what we call syngas. Syngas is a gaseous fuel that's produced by gasifying a solid material, in this case coal. Okay? So that's made up primarily of hydrogen and CO. Burns well. Both of them are good fuels. We know a little bit of methane in there, some few other hydrocarbons, but that's really what we talk about. So the first thing we're going to do, we're going to take that fuel along with the oxygen, compress them, and burn them in a combustor. Been done a lot. But what's different about what we're talking about with this cycle is we're going to do that at 4,000 psi. Now, if you're an engineer, I've got your attention all of a sudden. That's certainly outside the normal realm that we talk about. But by doing this, what we're able to talk about is we have that stream of CO2 coming out of this at supercritical conditions. So we take that, and you'll see that there's a turbine, so we run it through that turbine, through a heat exchanger, and then we're going to recycle part of that back. Why are we recycling part of that back? Because we can't burn that type of a fuel in pure oxygen. It'll get way too warm, really hot. So the adiabatic flame temperature of that is too high for the materials to handle. So we're going to dilute it with some CO2 and then run that back. So we've got a cycle we're going to bleed off, and that's going to be what we're talking about there. So coming out of this, then we're going to have high pressure CO2. Now, what do we see this as? We see this as an opportunity to really preserve the coal, or the coal option. The turbine is driven by supercritical CO2, NearZero emissions. I get excited and I'll say zero. Can't ever say zero. There's always going to be some level. But essentially what we're talking about is there's no stack on this plant. There's no smokestack. It doesn't exist for this one. So we're going to recycle that, bring it around, and you know the efficiency has changed significantly. If you go back to, I talked to you about that plant that we have out in Sherburne County there. I'm going to guess it's low 30s. I don't know the exact efficiency of that unit. What we're seeing right now, based on our analysis to date, is we're going to be close to 50%. So we're talking about a 50% improvement in efficiency, partially because we've got a whole different working fluid here, very different properties we're talking about. The other thing that we see, because of the pressure and the way this is going to operate, our footprint is maybe a fifth of what the plant was initially, the power plant, because things are smaller. High pressure, so you're going to have thicker walls, that type of thing. You got to contain that pressure, but a significantly different footprint. Right down the line, and then I'm going to show you there, why did we get excited? Well, pretty simple. The analysis we've had done, we've had a couple different engineering groups take a look at this, show that the potential is there, that if you didn't sell any CO2, in other words, you weren't able to do that, you're probably going to be somewhere between 6 and 7 cents a kW. If you're able to sell the CO2, we're estimating, and this is what we see right now, something between 4 and 5 cents a kW. Now, if you go out and build a brand new plant, you can't do that. You wouldn't be coming close, and you wouldn't be able to capture the CO2. That's not even talking about CO2. So we see this as a total game change if we can be successful. Where are we at right now? We've gone through what I'd call a pre-feasibility. We worked with the Electric Power Research Institute, asked them as an independent third party to take a look at what we'd seen so far. They did that, came back with a whole series of questions. The development partner we have in this activity is a group called Net Power. They're out of the Carolinas. They're a development group. And they are in the final stages of construction of a 25 megawatt electric natural gas-fired Allam Cycle. So in other words, that diagram I showed you before, it's the same, only there's no gasifier is basically what it amounts to. You're going to burn natural gas. Why is that a great thing? Well, basically, that's proving out the thermodynamic cycle that I'm telling you right now, I think is going to give you 50% efficient conversion of that thermal energy associated with that fuel to electricity. If we go down that path, you know, the good news is that's going to be operational, we're being told, right after the first of the year. We'll be down there shortly to take a look at all of the work that they're doing there. They are starting through the shakedown on that, and we'll start operation right after the first of the year, hopefully being online by about the end of the first quarter of next year. You always have to use some caveats on it. It's a first of kind. So, you know, this is not something where they just built one that they got bought down at the store down the street. This is a whole new thing. So we'll have to see where that goes. But this is fully funded and committed. So I'm convinced that that will happen. So right now, we are taking that early study that I talked to you about, and we identified a whole series of challenges, things that we have questions right now. People ask many times, are you convinced this will work, Mike? And all I can say is I don't have any reason why it won't yet. But that's where we're going. We've got to go through and prove out a number of things. And these are the areas we're working right now. Corrosion, very big issue. I talked to you about the conditions that we're going to see in that combustor, 4,000 PSI in a highly acidic environment. CO2 is an acid gas, okay? So we're going to have, there's some materials issues here. And, you know, when you've got water in there, so you're going to form carbonic acid. That's going to happen. So that's something we got to deal with somehow. So we're going through, and we've got a list of materials that we feel are candidates based on experience, and we're walking through them one at a time right now. We've got some that show real promise, and of course there are materials of that sort that have been put in the facility that's going to operate down in Texas. So we'll have that. A big step that we have to get through is a gasifier. Well, we know how gasifiers work. We've got gasifiers in North Dakota, been operating since '84, I believe is when they started up the Dakota gasification facility. So we've got 30 years experience on them, but we want to match this. This is a matter of making sure that this fits well with this technology option that we're talking about here. And so all of them have different properties. Maybe it's the type of gas that comes out, maybe it's some of the other impurities that you might see that are somehow being controlled in that system. So we've got to go through that, and we've got a list of 9 that we've gotten to so far that are still in the race. We hope to do a down select 2 or 3 yet this year. And this is work that's being done right now by a group which includes the Energy and Environmental Research Center and the sponsors, which includes Dakota Gasification, who knows a few things about gasifying lignites, and the friends at Net Power. You go on, and then we talk about impurities removal. Well, what does that mean? Well, basically, when we talk about the materials issues we have here, it's really an optimization program. Because we know when we gasify coal, we're going to have impurities in that stream. So we somehow have to manage them in different ways. And how we manage them and what's left is going to be a key factor in the types of materials that are going to be successful in that system. So if we take out more of something, maybe we can use a cheaper material, but it costs more to take it out. So those are the kinds of things we're going through right now, trying to do that optimization project and find out where we're going to end up with that. Now we've got technologies that we've seen that have been used that have removed all of these. It's a matter of how we put the box together is really what we're interested in right now. And then combustion modeling. The system has been fired at those pressures on natural gas. There was a test rig that was put together and operated out in California. That was an early on done by the developers because this was a potential no-go option. If there was a problem with stable combustion under that set of conditions, there wasn't. They were able to operate that. But it was operated for a short period of time. Now we have to operate this thing as you would any other power facility, which is 24/7. That's what we want to see. So we've got to get through that. And that's a key task that we're involved in right now, is trying to look at the modeling of that. And we want to do it with this other fuel mix, which is now basically CO and hydrogen. So where are we at? We've gone through a phase 1, addressing a number of the technical challenges that were there. That project is coming towards the end. It'll be done later this year. That's being completed by the Energy and Environmental Research Center for us. Phase 2 has already been funded, and we're finalizing that contract with them right now. These are both with the state of North Dakota through what's called the Industrial Commission. That's the other hat I wear. I'm a technical advisor to the Industrial Commission for the issues as it relates to the Lignite Research Program. Once we get through that, we go into a phase 2, which is going to be a pre-feed and scale-up. In other words, we need to talk about doing something more than what we're going to see on the lab or bench scale. We need to operate this thing. We need to do similar to what they're talking about down in Texas right now. Only we want to do it with syngas. So one of the options we've talked about would be to try to do this at Dakota Gas. They've got syngas already. It's already there, so we'll see where that goes. Then we get into a full feed study. That's a front-end engineering and design. And that means you're going to take and cost out every single thing that's going to go into that system, get a final estimate of what it's going to take to build that, and then finally, phase 4 is the commercial unit. Now this is the exciting thing. One of the challenges we've got, of course, is this isn't going to happen tomorrow. If you were asked me today when I think we'll be able to be through phase 4 and have the opportunity for a full-scale commercial unit, I'm going to say 25. And I'm being aggressive. These things don't happen easily, they don't happen quickly. There's a tremendous risk and a tremendous amount of things that have to happen right to make this all come together. But the payoff is tremendous, in my opinion. I mean, I just go back to this. This is where we started with this whole thing. If you look at it, these are the kinds of systems that are used today and what they cost. And this is a cost, I'm not talking about a series of government incentives that are going to change the economics of this. This is just the battery technology itself. And what you can see is this has the potential And particularly if we can do something, and when you see that error bar that goes to the left, that's what they talk about if we sell the CO2. In other words, that changes the economics significantly. And that's not a new concept. I mean, it's being done a lot. They're taking naturally occurring CO2 out of some natural formations, pipelining it down to Texas and using it for the last 30 years to do enhanced soil recovery. So this is something that's real, in my opinion. So with that, this is the one I've told many people I'm going to try to retire in this year. I don't know if I can do that when I've got something this exciting that's out in front of me. So this is the kind of thing that has a chance not just to offer a good opportunity, this changes the industry. And we're excited about that. We're looking to partner with others, the state of North Dakota, the federal government. Other countries are already starting to show interest. A number of companies around the world are showing interest. And we hope that we're going to be able to move this forward and to be able to show that we can do what we talk about. And the people that always say, what do you mean by clean coal? We mean it's clean coal, and that's what this is. And this would be very clean coal. So with that, I will stop.